Polyethylene is one of the most widely used thermoplastic in the world. It is produced through the polymerization of ethylene monomers. Polyethylene is popular because it is lightweight, flexible, chemically resistant, and durable. Now, let's move on to the main type of polyethylene. There are three major types commonly used in industry. The first one is LDPE, which stands for low density polyethylene. LDPE is flexible, lightweight, and commonly used for plastic bags and packaging films. Next is LLDPE, or linear low density polyethylene. Compared to LDPE, LLDPE has better strength and durability, making it suitable for scratch films and containers. Lastly, we have HDPE, which is high density polyethylene. HDPE is stronger, more rigid, and resistant to chemicals, so it is widely used for bottles, pipe, and industrial containers. Due to these properties, polyethylene is widely used in various industries such as packaging, construction, automotive, medical equipment, and household products. Examples include plastic bags, bottles, pipe, and food packaging. Polyethylene is popular because it is lightweight, flexible, chemically resistant, and durable. Different polymerization methods are used to produce polyethylene, and each method affects the polymer's properties, cost, and application. Therefore, understanding this method is very important in the polyethylene industry. The sections of the polymerization method depends on several important factors. First, it depends on the product requirements. Different product needs different properties such as flexibility, strength, and durability. Secondly, industrial efficiency is also considered. Manufacturers choose methods that are cost-effective, efficient, and suitable for large-scale productions. Lastly, environmental considerations play an important role. These include energy consumptions, waste generations, and the impact on the environment. By considering all these factors, the most suitable method can be selected to produce the desired type of polyethylene. The first polymerization method is bulk polymerization. Bulk polymerization is a method where the reaction occurs using only the pure monomer without any solvent or dispersive medium. A catalyst or initiator is added to start the polymerization process. In bulk polymerization, ethylene monomers react directly with each other to form polyethylene chain. As the reaction progresses, the mixture becomes highly viscous. One of the main challenges is this method is heat removal because the reaction releases a large amount of heat and there is no medium to absorb it efficiently. The advantages of bulk polymerization include its simple process and the production of high purity polyethylene since no solvent is used. However, the disadvantages include poor temperature control, difficulty in handling the viscous mixture, and the risk of runaway reaction due to excessive heat. Bulk polymerization is commonly used to produce low-density polyethylene or LDPE. LDPE is widely used in plastic films, packaging materials, and simple molded products such as plastic wrap and bags. Next, my teammate will continue with solution polymerization and emulsion polymerization.
The next method is the solution polymerization. In this solution polymerization, ethylene monomers are dissolved in a soluble solvents. The polymer reaction takes place between this solvent using a catalytic principle. The presence of the solvent helps to reduce the viscosity of the reaction mixture and improve heat control. However, the process requires high temperature and high pressures. After polymerization, the solvent must be removed to recover the polyethylene. Advantages and disadvantages. The advantages of solution polymerization include better temperature control and more uniform molecular weight dispersions. On the other hand, the disadvantages are high energy consumption, higher production costs, and the need the solvent recovery. Application. This method is often used to produce a linear low-density polyethylene, LLDPE. LLDPE is commonly used in additive coatings and specialty plastic products. Next is the emulsion polymerizations. Emulsion polymerizations occur in water, which the monomer is dispersed with the help of the surfactants. A water-soluble initiator is used to start the reactions. Principle of the emulsion polymerizations. The polymerization takes place inside tiny micelles. Water helps to control the temperature effectively and allows a high reaction rates. Advantages and disadvantages. The advantages include excellent heat control and low system viscosity. However, the disadvantages are difficulty in purification and the presence of the surfactants residue in the final products. This method is less commonly for polyethylene productions. Applications. Emulsion polymerization is mainly used for coatings, latex products, paints, and surface treatment. Next, we will move on to suspension polymerization and gas-phase polymerization.
Next method is suspension polymerization. In this method, ethylene monomers are suspended in water as small droplets. Each droplet acts like a mini bulk reactor where polymerization occurs. Water acts as a heat transfer medium, helping to control the reaction temperature. The resulting polyethylene is formed as solid bits, which is easy to separate by full correction. Next advantages. The advantages include quick heat control and easy recovery of the polymer. However, this method required stabilizing agent and often limited control over particle size. It is also not widely used for polyethylene. Suspension polymerization is used for granular polymer products and non-plastics parts with limited application in polyethylene products. Another important method is gas-phase polymerization. This method occurs in the gas phase where ethylene gas reacts over solid catalyst without using any solvent or water. For principal gas-phase polymerization. Gas-phase polymerization is commonly carried out in clear gas bed reactors. Ethylene gas flows through the catalyst bed and polyethylene is formed as solid particles. My teammate will be continuing the rest.
So today I will present about gas phase polymerization. So in the slide we can see advantages and disadvantages. So the advantages of gas phase polymerization include low operating costs, low solvent recovery, and better environmental performance. However, the disadvantages include catalyst sensitivity and the risk of reactor fouling. Next is applications. Gas phase polymerization is the most widely used method in industry. It is used to produce high-density polyethylene and linear low-density polyethylene, which is commonly used in pipes, containers, and packaging films. Next is comparative analysis. When comparing all 5 polymerization methods, each method has its own strength and weakness. For example, bulk polymerization is simple but has pure heat control. Solution polymerization produces uniform polymers but is expensive. Emulsion polymerization offers excellent heat control but limited use for polyethylene. Suspension polymerization allows easy recovery but has limited application. So, gas phase polymerization is the most efficient and widely used method. So, in conclusion, the choice of polymerization method greatly affects the properties and application of polyethylene. Gas phase polymerization dominates industrial production due to its efficiency and cost effectiveness. Understanding these methods helps industries select the most suitable process for producing high quality polyethylene products.